All right, starting the bivariate analysis. There's not a lot of numeric columns that we can look at today, but what we're going to do is look at the cat plot. So sns.catplot, data equals data frame, x equals legendary, and hue is by the generation. So we're going to do legendary, so one kind of separation on the legendary status, and we're going to also separate by generation to give us some texture in terms of the values of our values. So we're counting how many values are in false, and we can see that generation 1 has the most normal Pokemon, and where we see the lowest true or the lowest legendary Pokemons appear in generation 2. So it gives a little bit more texture in terms of the plot, and very, very easy with Seaborn to kind of get this level of detail. So here what we're going to do is look at a Pairplot. So bivariate plot of the continuous features, the list that I had assigned up above. What I'm doing right here is I'm just going to, I want to filter, I want to use the legendary to kind of add some texture to this plot. So we'll look at this and I'll just get this started while we're talking. And we're appending the legendary to that list. And then at the very bottom, you can see here, I'm going to pop it from the list. So I'm adding legendary to our continuous features, and I'm going to remove that from the list to kind of keep things nice and tidy, but I'm adding it just for this plot so that I can look at it and add texture and sort the hue by legendary. So we're doing feature, so data equals df by continuous, only the continuous features, and then we're going to go hue, legendary, kind is a hist, so this is technically a two-dimensional hist plot. Our diagonal kind is hist, and we're putting in some diagonal keywords. So we're going to change the diagonal plot here. We're going to go element step, fill true, stat is density, and line width equals 2. And this has some nice little effects in our plot. So let's zoom out here a little bit and let's look at this plot. So we can see here, let's go one more. And so we can see here, we have really the biggest thing to take away. We have legendary is false is blue and true is green. So we have some interesting things, but in general, we see that a legendary statistic has a higher, we have kind of upper and to the right, a higher general increasing of your overall stats, one for one. And the way to read this is, so the middle, the diagonal is a histogram that uses density to find the values, and this is by, so we go, if we're looking right here, we're going defense by defense, special attack by special attack. So when it's intersecting with itself, it's going to plot a histogram, just a regular histogram. And when we're doing a variable by another variable, it's plotting the defense by speed, attack by speed, HP by speed. And this gives us a lot more texture than just looking at a standard scatter plot, because the scatter plot, lots of those little dots, you can't really tell how many dots are really there. So this gives us, because we do have a few rows we're dealing with, this gives a little bit more texture to understand exactly where the density is happening. So we can see here that for attack by speed, the highest density of those values are happening right over here. We do have values all around our board. And so just having a standard scatter plot might lead us to believe that there isn't really a solid pattern here, but we're seeing that there is a huge density between attack and speed in this lower level, where attack is between 90 and 100, and speed is around just below between, let's say, between 50 and 75. We can learn a lot of things from this Pairplot with Seaborn. It's awesome and great to use Seaborn plots. So here what we're finding is the generation 3 has the most legendary Pokemon, 2 has the least. All stats have a similar characteristic, and each stat holds outliers. So legendary status has a general increasing effect across all statistics. And so the last thing is just looking to see if there's a correlation between each numeric feature and the corresponding category. So what we can see here is total has a higher correlation. We can see the darker color, a higher correlation. The Pokemon number, not really our concern for today, so we're not looking at that one, but has a high total. HP, and I would say the most noticeable one here is defense defense seems to have a correlation with special defense, and HP seems to have a higher correlation with things like attack, and total has a high correlation with those. So we can see the correlations, and we're just looking for the darker colors here to really separate which ones have true. So high total has a high correlation with defense and HP. So to get a high total is you likely are going to need to have a high defense and high HP as well. Total is a moderate correlation with speed, and what I mean here, so when we look at speed right here, you can see it's a little bit less intense. The color is less intense, and so we're not having as high of a correlation with that. Special attack and special defense and speed show some correlation. Generation has a very low correlation. Okay, so next we're going to head into the outlier inspection.